Well, welcome. Thanks for coming. Thanks for joining us this afternoon. My name is Philip Lok. I am assistant professor at ETH. I'm an architect and structural engineer. And because you probably wonder why the heck a structural engineer is moderating this session, I want to take the liberty to present myself very briefly for 10 minutes. I'll do that first, but I wanted to go over what you can expect this afternoon because it's nondescript. So we have three groups of students, no, not students, it's called young scientists. Even not all of them are young scientists, but we have three groups from Ethiopia. We met our friends from Ethiopia already. They're very eager to share also how they see their future. Then we have representation of the Future Cities Laboratory. So we'll have an input little presentation there also. And then from the urban farmers. So that is something very different. I'll introduce them properly later. Then after this, so this then serves somewhat as a fresh or different or kind of input or take on the topic of the conference. And then as you see, the chairs are already standing there. Then we'll go into an open discussion. So a chance to question a little bit more. Hopefully I asked all the young scientists, me included, being the youngest faculty at the Department of Architecture ever. Hopefully we say something that triggers your interest and that we can get a good discussion going. At the panel discussion, there will be also two people from the Swiss Study Foundation joining us, and they will introduce themselves, why they're there and what the Swiss Study Foundation is. But so as I said, I will blatantly take the floor myself and present 10 minutes who I am and what I do. So I'm in the Institute of Technology in Architecture. That perhaps still makes sense. So we saw already a few of my colleagues starting an interesting discussion this morning. Bear with me for a couple of minutes. I will talk about masonry, why that is relevant. Hopefully will make sense after 4 minutes. Because then you will see why my name was dropped twice yesterday, and particularly with respect to the Ethiopian project. Okay, so I went to MIT to study high-tech things, and instead I ended up looking at these historic structures. I just want to give a few numbers about these. These are basically shells in unreinforced stone, so they just stand in compression. There is no reinforcement, and they've been standing for centuries. The span is about 13 meters, and the thickness goes from 10 centimeters to 15 centimeters. If these numbers don't directly ring a bell, perhaps this image might. It's actually about the same thickness to span ratio as an eggshell, whatever the span is in an egg. Why am I talking about this? Because masonry structures are very different than our typical materials that we use. There's two extreme ways to look at structures and structural materials. One, you can design them for stress. That means you design them for material failure. That is our modern structures. But then actually the masonry structures fall in this next category. That is, they actually need to have a good form, because there is nothing holding that together than just the compression of the flow of forces. So if they don't have a good form, then they will collapse. That is also why in the Middle Ages they did all these spectacular things. My introduction at MIT was here with this book by Wolff, and as you see, it was 42 years ago that anyone touched this book, so it's a very hot topic that I was doing there at MIT, right? So, but we want to explain these things. Please bear with me. It will make sense why I'm looking at these things and how it fits within the urban stuff, right? But here, so first we want to explain these very highly sophisticated shapes. So for this, this is a follow-up of my PhD dissertation. We developed these tools that explain this. Okay, but this is digital. We already talked a little bit about digital. You can do whatever you want with digital, so that doesn't mean anything. So we also look actually at, we do physical tests, and the reason that it's a property of geometry and not of stress, these little models actually act exactly the same as a larger structure. Maybe you recognize two of the people in the screen there. So that is the president and the vice president of research of ETH. And I could catch them for a quick 2-minute demo, and this is the result. So let's maybe They seem at least intrigued of what's going on. What I'm doing, I'm basically modeling and simulating displacements, what happens over time in historic structures. You see I'm sweating profusely because I was a little bit nervous. So that's what happens when you abuse masonry structures too much. So they enjoyed it. Everyone loves destruction. So then they go and... anyway, it was a great moment of fame. Okay, so what is now the link? The link is unreinforced masonry structures need to have a good form in order just to stand, otherwise they would collapse. So then the link is, if we understand this and we learn from these old master builders, the old designers, then we can design new, efficient and expressive structural form. Okay, so what does that mean? We have a lot of this going on. It's also related to the digital, but I would avoid or try to avoid to have to do it with a lot of material that is not necessary. All right, so actually, already looking back to the past, I want to give a little bit of an explanation about these spiral staircases. They have no steel in them, they have no reinforcement, they're just standing in balance, and they're actually also built without any formwork, so they're just built in space. This is done using Catalan vaulting, these are in New York. I think already these shapes are pretty sensational, and they're not done with an excess of material and waste and all of that. So then we do things like this. Indeed, again, the little models, this stands without any glue. And so this was our first little test of showing some parts are only 2 millimeters thick. The sound is not running, but that's maybe okay. Again, you need to destroy everything. This is also just, these models are very important, and we'll get to this because a part of this is also educational on how to transfer this kind of knowledge that the old masons had. And so you see that these vaults have a lot of capacity to stand. You see also that I'm not cheating with images, that it's really a structural thing, and that it's stable until, of course, you do a little bit too much abuse. Anyway, so collapsing things is pretty fun. If you wondered how we made this little cake form, we flip it over, it has the supports and then it stands. So with this, oopsla. Okay, never mind. So another thing, little scale models is fine, and this is then getting towards why it becomes relevant. We try this also out there directly with traditional techniques, these new forms, and to try to realize that. That's Lara Davis. She was PhD student with me. Now she is with my colleague Dirk Hebel pushing these ideas further, but the idea is this is built with no formwork in space. So this was just to show that looking at the past you can do exciting things, of course. So this was a little showcase we did. This is not finished, but just to show that just the quality or the interest of understanding these master builders to do something that people do not assume that it can stand. For example, my colleagues in civil engineering, I'm associated to civil engineering, they insisted that there had to be tension everywhere. That is not possible because there is no rebar in the structure. To be taken seriously as a potentially master builder, we needed to do some ghetto testing, so that's why this highly precise Swiss testing situation is going on there. Unfortunately, nothing happened. We hoped for a spectacular collapse, so that was a really good lesson. You learn actually the most by making things fail rather than making things succeed. So we needed to do something else. So Matthias made digital tools, so he was really excited. It was a good day. Maybe those of you that do these kind of things also.
Keep going, keep going.
That's my overly excited postdoc. You see, he's not used to handle these kind of heavier tools than a mouse, but.
Wait.
Well, it was an exciting day for all of us, right? Okay, that is, I will not explain why that is strange, but you get the picture, it had to come down. So the good thing is, again, we learned about this, and so we are really trying to translate this, and this is important. All right, this is now important for the next thing, because of course you cannot just do all this innovation only digital on your computer. You need to have these grounds. That is the other thing. So I already said unreinforced masonry needs a good structural form to stand. And then another aspect is not only that we can do new design applications, but if you have a good structural form, so basically you shape your structure where the forces want to go, then the stresses in the material are very low. And so that means that you can either build with very little or very low quality material. And so now we're getting there. So this is a project that I was fortunate to be part of during my PhD still. Maybe you remember this. It won about every possible sustainable award you can win. It's basically using soil-pressed tiles that are cement stabilized as structural material. That is very surprising because it's not at all a structural material. But because we use good structural form, we can use the local dirt. So this was in South Africa. It was a poverty relief program. The people, local people, were trained by, that's Michael Ramage, now at University of Cambridge. That is our master mason. You see, not really being sure about what's going on. And then this is actually the very first vault that they did. So there is actually all the wood that you see is only to guide, to make sure that we have the good structural form. We are talking about non-skilled laborers. 2 weeks ago, they were farmers, so now they're building this technique that we introduced with a new material from Catalonia, Catalan vaulting. And so these are just basically in dirt, so they are literally also dirt cheap because you just use the local material and the locally available people to work on it. Let me skip the rest. All right, a great thing there, and maybe I don't have, maybe we can share this later, but it's always great to introduce new technologies and the empowerment that comes with it and the pride of learning a new trade, a new skill, and to get there. So this was the very first vault I built. Just to emphasize again how thin a structure can be if you know where the forces want to go. And remember, this is just compressed soil, so it's not baked, typical bricks, and that is where we're getting, that if you are planning, you are designing new cities, new towns. This was actually initially thought of also as a possible application for the nest town. At a certain point you need to construct it, and so if this really becomes a model for many other places, then this is a chance to really also push these sustainable aspects, these appropriate construction aspects within the project. To give you a scale again, this is a vault of 18 meters, just standing in dirt. And so the other thing about this is, and this is why it was initially, we tried to introduce it, is that this is really dirt cheap, but it doesn't look cheap, and that is important. When we presented this, we had several occasions to present this in Ethiopia, then they asked me if I would want to live in the solutions that I provided, and I really like this, so I would. If you use local materials, it nicely blends into the landscape. Some more images. This was Peter Rich, architects with John Oxendorf and Michael Ramage. I did the structural engineering of the vaults afterwards. It won World Building of the Year 2009. So if you recognize that that was a building by Frank Gehry, so we beat Frank Gehry in 2009. Okay, so why could this be relevant? Here, this is now what is called the low-cost housing solution for urban applications in Ethiopia. It is only low cost because there is a lot of subsidy in there, and that is clearly because they are trying to mimic Western models, which we all understand. But many of the things that you need for this, like precision wood, formwork, all of that, mortar, steel for the reinforcements, all need to be imported, are expensive, and thus perhaps not the best model. Then traditionally we saw already these very nice vernacular traditional things. The use of wood is not in the best way perhaps. This is a modern interpretation. You can imagine that there is all kinds of challenges that we need to assess there. Yeah, sorry. So then together with actually initialized by Dirk Hebel, he will present a little bit more in detail why these kind of things are important to really work with local materials and what you can do with it. We did this ZUDU, this Sustainable Urban Dwelling Unit. Marc-Angelil also talked about this. And there you see that this hanging chain is there. This hanging chain is exactly where the compressive forces want to go if you invert it. So to have this there as a physical thing that can be safely reproduced is very important. The training of the people on all levels, so both vocational, the planners, the architects, the building managers, and even the workers, so that is very important. We did several of these workshops. Important though, and that is why it then ended up failing in the Neston project, is that when you want to introduce this kind of localized ideas, you need to also understand the local problems. And exactly this you will hear about much more tomorrow. And this we did then with some experts, and we assessed that basically on the site in Baradar you cannot use these technologies. And so this is also important. So we try to teach the people to be responsible, because if you see the example that we made and we don't explain why it was designed like that, then it is very dangerous, and we are doing non-safe technology transfer. So here again Lara is involved. And so this was then built. This was then also framed as a workshop with ETH Sustainability and ETH North-South. And this was to exchange really between the students from the Institute of Architecture and Building Construction and City Development in Ethiopia and the students of ETH. That's, by the way, where I met our very enthusiastic friends for the first time. And these are just some images of the results. And this was the outside. This was designed by a colleague of ours at the Institute. So this is what they wanted. So it actually looks like a concrete box, but it is done with 85%, something like that, really local materials. So this is really a success to show that the language that they want to show modernity is actually exactly possible with local materials. So I'm wrapping up. Sorry, I took 5 minutes, but to my excuse, there were some challenges. By looking at the past, you can really learn. We also heard from Christian Schmidt that often goes wrong, particularly in engineering. There is no tradition to look at what things were done before. Engineers nowadays are extremely arrogant. They think that they're at the pinnacle of knowledge, and that is not at all like that. So luckily, in architecture, in urbanism and all of that, there is this history, this trace, this argumentation and all of that. And so I just showed a little bit what I do, that you can even literally in masonry apply this in many ways, many exciting ways. But this is also a vehicle to show that you can do exciting and efficient structures with many applications if you understand how they work. I just wanted to, because I didn't put any proper credit on this. I don't like to do that, but it's more visible like that. Please go to my website if you like what I showed. Easy to remember. I play with blocks, and so block, point, arch, and so on and so on. Anyway, that's me. So let's maybe then go to the inputs. We'll start with our Ethiopian students.